Okay, this presentation is about simultaneous equations, which is when there is a system of equations with more than one solution. So here's an example of a single equation: 4x plus 5y equals 47. Now you can think of any number of solutions that you like for that, because whatever you think of as x, then you can make y fit. So for example, if x is 1, then you can figure out that y has to be 8.6 to make the whole thing 47. If x is 2, then you can figure out that y would have to be 7.8 to make the whole thing add up to 47 again. So you can just think of any value of x and then work out what y needs to be to make it work. 3 and 7, and so on. And equally, there's another equation, and you can think of infinitely many solutions to 8x plus 2y equals 38. For example, if x is 0, then y would have to be 19, so that you get 0 plus 38 equals 38. 1 and 15 work. 8 plus 15 equals 38. 100 and minus 381. You can think of any value you like for x and then just make the y value so that it works out that the whole thing comes to 38, and so on. So each of those separately has as many solutions as you care to work out for them, but there is only one solution for x and y that works in both of them at the same time. At the same time, another word for that is simultaneously, which is where we get the title of the topic, Simultaneous Equations. And there's three ways of working out what those values are. First of all, with algebra, so you've got the two equations: 4x plus 5y equals 47, that's equation 1, and 8x plus 2y equals 38, that's equation 2. Now if I double everything in equation 1, then instead of 4x plus 5y equals 47, then I've got 8x plus 10y equals 94. So I've doubled everything in the first one. Well, what was the point of that? Well, the point of that is now that in both of those I've got the same amount of x. I've got 8x. So that if I do one equation minus the other equation, the x's disappear. 8x minus 8x is nothing. 10y minus 2y is 8y. And 94 minus 38 is 56. So that leaves us with the x's having been eliminated, and we're just left with 8 times y equals 56. Well, if 8 times y is 56, then divide everything by 8, y must be 7. And once we've worked out what y is, we can figure out what x is. So take the first equation, 4x plus 5y equals 47. Now we know that y equals 7. We can put that in there and write 4x plus 35, 5 times 7, equals 47. Well, it should be easy to figure out what x is now. Take away 35 from both sides to leave you with 4x equals 12. And divide both sides by 4 to leave you with x equals 3. So 3 and 7, x equals 3 and y equals 7, is the solution to this thing, which means that those values work in both equation 1 and equation 2. Well, let's just check that out. We know that it works in equation 1 because we used equation 1 to work it out. But if we put those numbers into equation 2, 8x plus 2y equals 38, 24 plus 14 does equal 4. Here's another way of doing it. So the first equation was 4x plus 5y equals 47. The second equation was 8x plus 2y equals 38, which we can rearrange a bit to make into y equals something. Well, now that I've got what y equals, I can put that where y is in the other equation. So instead of y there, I'm going to write 19 minus 4x. 4x equals 5 plus 19 minus 4x. Sorry, 4x plus 5 times 19 minus 4x equals 47. Because y is 19 minus 4x. Well, the point of that is that you can multiply it out, and it's only got x's in it, and because it's only got x's in it, it's easy to solve. So you multiply the brackets out, you get 4x plus 95, 5 times 19, minus 20x, 5 times minus 4x, equals 47. Well, we've got a 4x and a minus 20x that makes minus 16x when you put them together. So the next stage is minus 16x plus 95 equals 47. And then we can take away the 95 from both sides to give you 16x equals minus 48. And then finally we can divide everything by minus 16 to find out that x equals 3. Now that we know that x is 3, we can put that into equation 1 or equation 2, but I put it into equation 1. 4x plus 5y equals 47 becomes 12 plus 5y equals 47 because x is 3. Take away the 12 from both sides, 5y equals 35, divide both sides by 5, x equals 7, and then just use the other equation to check it. 8x plus 2y equals 38, 24 plus 14 equals 38. That works, so we know we've got the right answer. So it's the same answers again, x equals 3, y equals 7, but a slightly different method. Third method is doing a graph, or two graphs. 4x plus 5y equals 47 can be rearranged. Take away 4x from both sides, divide both sides by 5, and we can see that that's the same as y equals minus 0.8x plus 9.4. Similarly, the other one, take away 8x from both sides, divide both sides by 2, and we can see that that's the same as y equals minus 4x plus 19. Now, with those written in those formats, y equals something x plus something, it's easy to make graphs of them, because we know that the number on the end is where the graph cuts, and the number in front of x is the gradient, how steep it is. So we make the graphs of those. The first one, y equals minus 0.8x plus 9.4. It's a graph that cuts at 9.4, and then for every 1 across it goes 0.8 down, because the gradient is minus 0.8. The other graph, y equals minus 4x plus 19. It's going to be a graph that cuts at 19, and then for every 1 across it's going to go 4 down, because the gradient is minus 4. 1 across, 4 down. Those two graphs meet here at the point 3, 7, where x is 3 and y equals 7. 3 along, 7 up. X equals 3, y equals 7. So that's another way of finding that x is 3 and y is 7 is the only pair of solutions that works in both equations.